This lesson is on the special right triangles that exist. There are two of them. We call them special because they are some of the most commonly used types of triangles. For example, this isosceles right triangle is half of a square, and a lot of times we'll look for the length of the diagonal of a square. A lot of times we use 30, 60, 90 triangles. Well, it is half of a rectangle, so that is one common use for it. There are other uses. Because they get used so much, the ratios have actually been figured out for us, the ratios of the sides. So this is one of those lessons where if I give you one side of the triangle, you can find the other two sides of the triangle based on what kind of angle measures they have. If it's a 30, 60, 90 triangle, that means the angle measures are 30, 60, and 90. And based on whatever the shortest side is, the one that sits across from the 30, you can determine what the hypotenuse and the other leg are. These tend to work differently than the Pythagorean theorem. With the Pythagorean theorem, you have to know two sides of the triangle in order to find the third side. With these, you only have to know one. The other one is the 45, 45, 90. Since two of the angles are the same, that means two of the sides are going to be the same. And then the third side is just the square root of 2 times whatever the length of the other two sides are. Okay? This one in the 30, 60, 90, whatever the length of this side is, the shorter leg, the hypotenuse will always be twice as big as the shorter side. The other relationship is from the shorter leg to the longer leg, you simply multiply by the square root of 3, and that's how you get the length of the longer leg. These do go backwards. Okay? For example, if I give you the length of the hypotenuse in the 30, 60, 90 and ask you to go backwards, instead of multiplying by 2, you would divide by 2. And if I give you the length of the longer leg and ask you to find the length of the shorter leg, instead of multiplying by the square root of 3, you would divide by the square root of 3. Same thing here. To go from the legs to the hypotenuse, we would times by the square root of 2. To go backwards to one of the legs, we would divide by the square root of 2. That's how the relationships work. It's kind of like a map. Okay, let's try some of these examples. Okay, so example number 1. I give you that you have a 60-degree angle and a right angle, which means then that this one would have to be 30. So you know it's a 30, 60, 90 triangle. And the length of the hypotenuse is 8. So you go back to the ratios and say, okay, if I have the hypotenuse and I have to go back to the shorter leg, what is the relationship? So you go back to the other page and you say, okay, if I'm here and I have to go here, that means that I have to get rid of the 2, so I have to divide by the 2. So I would divide by 2, and the length of this side would be 4. Then to go from the shorter leg to the longer leg, go back to your ratios. To go from the shorter leg to the longer leg, I have to multiply by the square root of 3. I would simply leave it as 4 times the square root of 3. That is how I would leave my answers. The question always comes up, can I go right from the hypotenuse to the longer leg? And the answer is yes, but what you have to do is divide by 2 and then times by the square root of 3. The next one, 30, 60, 90 triangle, so I'm still using those same ratios. This time I give you the longer leg, and you have to work your way back to the shorter leg and up to the hypotenuse. Looking at this, at the ratios, if I start with this one and I have to go backwards, I have to divide by the square root of 3. So I would take 5 times the square root of 3 divided by the square root of 3, and my square roots of 3 cancel, so the side length would be 5. Then how do I go back from the shorter leg to the hypotenuse? I have to times by the 2. So I would take 5 times 2, and the length of my hypotenuse would be 10. That's how you go back and forth between the side lengths on a 30, 60, 90 triangle. As for these two, I notice that these are 45-degree angles and 90, so I know I have a 45, 45, 90 triangle. So I go back, look at my relationship. The legs are going to be the same length. And then to go from my legs to my hypotenuse, I would times the square root of 2. If I have my hypotenuse and I have to go back to my legs, I would divide by the square root of 2. So here, this is one of my legs. So I know my other leg will be exactly the same length. And then to go from my legs to the hypotenuse, I take that value times the square root of 2. This one, if I start with the hypotenuse, I have to work my way back to the legs, so now I have to divide by the square root of 2. We learned that you can't leave a square root in the denominator, so you have to simplify it. We learned to simplify it, you multiply it by itself. When you multiply it by itself, on the top you would get 14 times the square root of 2. On the bottom, square root of 2 times the square root of 2 is simply 2. 14 over 2 is 7. So the length of my sides would be 7 times the square root of 2. There is a pattern here if you notice. When you divide by the square root of 2, the pattern is that that number becomes half times the square root of 2. That will always be true. You take whatever this number is, take half of it, and times it by the square root of 2. And that is how you get backwards from the hypotenuse to the legs in a 45, 45, 90 triangle. The homework for section 8.2 is as follows. There is a second part. There is a day 2, if you'll notice. Day 2 for geometry and CT geometry. That encompasses this next slide. It says this, okay? So if we know that if we drew a diagonal and a square, we know to make a 45, 45, 90 triangle. But how else can you tell if you have a special right triangle? Okay, so for example, if you have a right triangle that has a hypotenuse of 12 and has a shorter leg of 6, is it a special right triangle or just a regular right triangle? The answer is you have to look at the ratios. Okay, in this one, the hypotenuse is twice as big as the shorter leg. So you go back to your ratios and look. Is that relationship, does that occur in either of those triangles? That the hypotenuse is twice as big as the shorter leg? And in this case, the answer would be yes. In a 30, 60, 90 triangle, the hypotenuse is twice as big as the shorter leg. So the answer to this question is yes, it's got to be a 30, 60, 90 triangle. And to get to the length of the third side, the relationship, back up to your ratios. How do you go from the shorter side to the longer side? We times by the square root of 3. So we would take 6, which is the shorter side, and we would times it by the square root of 3, and that would be the length of the other leg. That concludes the entire lesson for section 8.2.